So thank you very much for the introduction. My name is Asim Houssein. You can find me on Twitter at Jawache, not Jawashe. And I blog about Angular and JavaScript. And well, very, very soon you're going to see some articles on machine learning on my website, codecraft.tv. And I have worked at the European Space Agency and have done some work for Google, but I currently work at Microsoft, where I'm what's called a cloud developer advocate. So we're a new team. Sorry, no. We're not called cloud developer advocates anymore. We're just called cloud advocates. We're a new team inside Microsoft. We're the open source advocates. So you can find if you go to this link here, you'll find all of us really. And each of us specialize in different areas. My specialty is JavaScript. We are wherever you are. So if you're on Twitter, we're on Twitter. If you're on LinkedIn, we're on LinkedIn. If you're on Facebook, we're on Facebook. So you can find all of our details there, and you can contact any of us about anything. I'm also an instructor on Udemy. Does anybody use Udemy here? Quite a few. Any of you my students? One. Hi. Thanks. So Udemy added in last year. They added in automatic subtitling for the videos, and so they correctly transcribed my name to Awesome. So my name is Awesome. And very, very recently, I also had a son, actually 5 days ago. Little Micah was born. Isn't he awesome? Yes, thank you very much. But in reality, he usually looks like this. But still cutest kid ever. Another way to think of me is probably this image here. Okay. This has been me over the last year. This is actually not me. This is my friend Eleanor's slide. So Eleanor and I are really good friends. We go back quite a long way. And earlier on this year, well, we're both actually interested in machine learning. We're both JavaScript developers. And earlier on this year, we were just sitting down after a long hike, and we're talking about machine learning, talking about JavaScript and machine learning. Lots of interesting, exciting things are happening in the JavaScript and machine learning space. And we thought, well, why don't we go and create a meetup group? And that's exactly what we did. And we created a meetup group in London called AI JavaScript. It's only been running for about 6 months. It has grown phenomenally fast. We're running about 2 meetups a month now. If anybody's interested in starting an AI JavaScript group in your own city, give me a shout. We're getting together a bunch of materials and workshops and things you can run in your own meetup group. So give us a shout. And one of the things that started happening, when we created the meetup group, was people started to send us links to really cool JavaScript, AI-powered JavaScript applications, really cool demos. And so we thought to ourselves, hey, wouldn't it be great if there was a place, if there was a website somewhere we could put all of these demos? And that's exactly what we did again. We created a website called AI.js Rocks. If you go to the website, what you'll find is just a whole bunch of different AI-powered JavaScript applications. The criteria for being on the website is that you have to be clickable demo. You have to be able to just open it up and try it out in the browser. But at the same time, the demo is also going to have at least a link to the source code, hopefully a link to some more documentation about how it was built. So the idea of the website is a resource to be inspired about what you can do in AI and JavaScript these days, but also so you can learn a little bit more about how to implement these types of applications yourself. And so in this talk, what I'm going to be doing, I'm going to be talking about AI and machine learning in the context of JavaScript by going through a few of the demos that people have submitted to AI.js Rocks. Okay, and I'm going to show you how the demo works, and I'm then going to explain to you how, a little bit more detail about how it works under the covers and kind of perhaps what tools and libraries it uses. All right, let's just see if the clicker works. Damn it. Okay. All right, first one. The Emojifier. It's not trademarked. It's just the emojifier, so I thought it made sense. So the emojifier is going to change the world. Yeah. What it does is it takes an image, and can anybody guess? What did you say? Turns it into an emoji. Well, yes. What it does is it detects any faces in the image. That's pretty impressive to begin with, right? Detecting faces. It detects any faces in the image, figures out the emotion on the face, then calculates the right emoji and places it on the image. Okay. As I said, it's going to change everything. I've had a couple of different incarnations. The latest incarnation is actually as a Slack bot. So if you go to themojifier.com and you click that Add to Slack button, it will actually be added to whatever Slack workspace that you have. And once it's been added, you can basically... Is the video? Yes? You can basically take any picture, random picture in the world, type /mojifier, the URL of the picture, and it'll mojify it. It can also handle multiple faces in an image. There we go there. Emojifies them. And it can help answer age-old questions which have plagued society for hundreds of years. And there we go. Answered. So the Mojifier does a bunch of different things. There's a couple of different parts that's involved in it. But I think one of the most interesting parts about the Mojifier is how it basically calculates emotion. That's pretty interesting, right? Like, how do you actually calculate emotion from a face? And I've got really great news for you. It's incredibly easy to detect emotion from a face. It just involves two steps, just two steps. Okay? First step, you've got to detect the facial features. So on any given face, there's some kind of well-known facial features. For instance, you can imagine positions of the pupils, lip. I think there's a little point on the lip here. I've forgotten what it's called. That's a famous facial feature. And there's a bunch of different libraries. You can use JavaScript libraries as well, which way you can give an image, and it can give you the different facial features of that image. Okay? Detecting the facial features. Step number one, incredibly easy. Step number two is even easier, though, because with step number two, all you need to do is use a neural network. All right? Cool. Oh, do you need me to explain? Do you want to explain your... OK, I'll explain it for you. Thank you. So neural networks, I'll just go through neural networks just briefly for those of you. But yeah, neural networks have a basis in biology. Okay? So our brains are made up of billions of these neurons. And a neuron has some dendrites feeding into it, a cell body, and some axons going out. So if enough electricity fires in the dendrites, the body might go, OK, fine, I'm going to fire some electricity out of the axons. That's it. If you stick 1 billion of these together, you get something like one of you. Well, I personally think there's a little bit more involved. I believe in a certain consciousness. But you get something pretty intelligent in any case. But if you think about it, you can actually implement this in code. Right? Just implement it in code. If you're writing this in JavaScript, you might just have a single node, class node, with some edges coming in and some edges going back out. Maybe you pump some values into the edges. Maybe this is house price increase, number of coffee shops opened up in the last year. An actual study done in London showed that an increase in coffee shops increased house prices, believe it or not. And then what you might do is you might add what these things call weights to the edges, which initially you might just have them as random numbers. Okay? So things going in are the features of your data set. And then all you do is you multiply them all together, add them up, and you pass it through something called an activation function. And whatever the activation function, it's just a function, right? It's just function. Activation, all it is. And whatever that function returns, you pass out. And that's it. You just connect a bunch of these together and you have a neural network. To show you a little bit more on the screen. Yes, animations. And that's all that's really going on. It's just taking some inputs, multiplying them by some weights, adding them together, passing them through an activation function, getting another value, connecting a bunch of these things together. You can have lots of different types of activation functions. It's the very, very simple one I used in that example. It's a simple threshold function. Anything below 0 is 0. Anything above 0 is 1. There's lots of different types of activation functions. But essentially, that's it. With a neural network, that's mostly what you're doing. Just multiplying. I actually get really annoyed with these kind of memes that I see flying around about AI and machine learning. I always see these memes out there that, it's just if statements. AI is just if statements. It's not. It's not. If anything, AI is multiplication, right? The way to think about it a lot, I think a good way to get introduced into the idea of what you're building here is, imagine you had to build a computer program and the only thing you could use was multiply. You'd have to think about things differently, okay? A large part of machine learning involves that. And that's why you have to really think about your problem set a little bit differently. You can't just throw an if statement in the middle of somewhere. You just can't. You have to think about, how can I solve this with multiply? And that's basically what you do, is you grab enough of these artificial neurons together and you put them in different layers. This is a simple 4-layer feed-forward neural network. You have 3 input nodes, 1 input layer with 3 nodes, 2 hidden layers, and 1 output layer with 1 node. All of them with edges. They're the same as what you saw before. You just initialize all these different edges with a random number. That's the weight. Just a random number. Then maybe you get some data set, a data set that you know, a data set of images where you know whether the image is happy or sad or something like that. So you grab your input image. You get the features from that image, perhaps the positions of the pupils, the mustache, something like that. You feed them in as the input nodes. And then you just do that multiplication. All you're doing is that multiplication. That's all you're doing. That simple multiplication through the weights, and it comes up with a number the other side. Maybe 0 is unhappy and 10 is happy, but I know 3 is wrong. I know because I looked at this image, and I know this image is actually 8. It's actually happiness of 8. So that means that this is wrong. 3 is wrong. It's off by 8. It's actually off by 5, sorry. Okay? What we need to do is we need to change those weights so that when we feed in those numbers, it gives us 8. That's the challenge. And what we do is we use something called backpropagation. I'm not going to go into it. It involves actual maths. Okay? I'm not going to go into it. But it's something called backpropagation. That process is basically just, you know you're wrong by 5. How do you change these weights so that, how do you tune them so that next time round you pump in these numbers, it's going to give us 8. That's the training. That's the learning in machine learning. Just that process of adjusting and tuning weights. That's all you're doing. Okay? And that's it. That might be how I detected emotion in an API. What you then do is once you've trained one of these neural networks, you can then basically take that model and you can save it somewhere. Okay? And then they're usually quite large, or they can be quite large. You probably don't want to download it or have it all loaded up in the browser in one go. So what you might do is then wrap it up or put it on a server somewhere, wrap it up in a little API, and then pass it an image in a post request maybe, and it returns you the emotion in an API request just to save on load time. That could be what I did. That could be what I did. But I didn't. I used an API instead. Okay? So I used the Azure Cognitive Services API. Okay? So it's called the Face API. And I'm always I don't really like this image we have on our website. I don't think the person looks very confident about this product. Looks a little bit confused, actually. I think we need somebody who looks a bit more like, aha, right? But that's it. This is the Face API. This is a bunch of a suite of services from Microsoft Azure called Cognitive Services. A lot of the common AI problems that you're going to find around a lot of the different platforms out there have APIs that support it. Okay, they make them easily available. This one's incredibly easy. You can just pass in a path to an image, post it to your URL, and it returns you some data. It returns you an array, one for each face. This is actually a subset of the data, not all of it. It returns you an array, so for each face, it will turn you the rectangle of the face. You need that, because if you remember, we're placing emojis on faces. And it also returns you an object of emotion. Anger, contempt, disgust, fear, happiness, neutral, sadness, and surprise from 0 to 1. Put your hands up if you've got a beard. If you have some very bad news for you. If you have a beard, you cannot be 100% happy. I've tried. You can only be 99% happy. Okay? You're 1% more depressed than everybody else without a beard. And that's it. That's what you use. So I just basically took that information, mapped these emotion information to an emoji, and placed that on the image. So to summarize all of this, is one thing I want you to take away is that neural networks are just incredibly powerful. A large part of what you've been hearing about machine learning and AI and machine learning and the growth in this space in the last 5 years is driven by neural networks. But the other thing I want you to take away is that conceptually they're quite simple to understand. I showed you a very, very simple feed-forward neural network. In about 5 minutes, I showed you the basics of it. Okay? There's a lot more, obviously, to learn, but the basics of it you can get quite easily. Okay, next one. Next one's going to need a little bit of explanation. Okay? Weird title. In that meetup, we do I ran a workshop in our AI JavaScript meetup group a couple of months ago. And I have a T-shirt which says, Azure, puppies, and I'm fine. Long story. Just accept the fact that that's something written on the T-shirt. And afterwards, after the workshop, a guy called Oliver Turner went away and built an application he called it TensorFlow MobileNet, and I'm fine. So that is the reason for this title. I'm going to show you the application that he made. So it's just a simple code pen. Oh, I haven't got the link to the code pen, unfortunately. Oh, it's on the URL there if you want to grab it. And what it does, it's got an image here. And if you look at the bottom here, hopefully you can see it. It's actually giving you probabilities of what it thinks is in the image. So it's a little girl, but anyway, it says miniskirt. Sandbar, so it's on a beach, pretty good. And seashore, coast, seacoast with a hyphen. It's okay, not bad. And then you can actually click around, so you can search puppies. This is going to do an API request to Unsplash for an image of puppies. But, well, not really, but it's doing a pretty good job of saying it's a coat at least. I don't know what a stole is, but is it stolen? I don't know. We're saying it's a duck-billed platypus, so obviously that isn't doing a really great job. Let's have the next one. Okay, that isn't really that good. Let's try puppies again. Oh, terrier. It's okay. What's the final one? Okay, yes, it's a T-shirt. Well, it's a person wearing a T-shirt. So, okay, sometimes it does an okay job. Most of the time it does a bad job. But the important thing to know about this demo is the only API request it was making was to Unsplash to get the image. Everything else, the detection of what's inside the image, all of this stuff is done in the browser, in JavaScript. Okay? And it's using a technology called TensorFlow. Has anybody heard of TensorFlow here? Has anybody used TensorFlow here? 5. Okay, the next 5 minutes you can just, entertain yourselves. So TensorFlow is it's a tool that likes to train machine learning models, and especially useful for neural networks. It was developed by Google Brain and open source in about 2015. It's quickly just become one of the standard ways of developing and training neural networks. But the really exciting thing, but TensorFlow itself is written in C. It's an application you install on your computer. The really exciting thing is about 6 months ago, they released TensorFlow.js. Ooh. And I think when I first saw TensorFlow.js, I just thought, oh, OK, it's just bindings for the C application. In order to use TensorFlow.js, you had to install TensorFlow. That's what I thought. I was wrong, because TensorFlow.js is a complete rewrite of TensorFlow in JavaScript. Why is that important? It's important because of this. Okay? In order to use TensorFlow in your JavaScript applications, all you need to do is just that. There are no other dependencies. Okay? You just do a simple import statement at the top. Well, you do import star as TF if you're a proper JavaScript developer. If you're like me, you use script tags. Okay? And that's it. You just have to drop a script tag in your page, and you can start doing machine learning in the browser. No other dependencies. Pretty exciting stuff. And you can do a bunch of different things. You can do a bunch of different things with it. So you can train models. So you can do that thing I showed you before, where you've got the weights and the back propagation, and it's tuning those weights in the neural network with more training data. You can do that. You can do that with TensorFlow.js. But a really exciting thing about TensorFlow.js is you can just load pre-trained models. That's it. TF load model and some JSON file which points to an already trained model that someone has exported and made available somewhere. Okay? And that's what Oliver used in that demo. He used something called MobileNet, which is a pre-trained neural network that has been trained to be able to detect 1,024 different things in the world. Just 1,024. It's MobileNet, so it's small enough to be able to load it up in the browser. And that's it. This is all you need to do to be able to do that. Load MobileNet. MobileNet.load is just doing that TF load model underneath. And then you're just passing an image. It's called classify. It's getting the predictions, and just logging the predictions on console log. But that's basically all of the complex machine learning stuff that Oliver did in that application is in about 4 or 5 lines of code. Pretty interesting stuff. But there's a trade-off, right? MobileNet is, it can only do 1,024 images. It can only recognize 1,024 things. It's been done in that way so it can be small enough to be able to load it up in the browser. It's still a very, very large thing that you want to load. You wouldn't want to load it up unintentionally. It's quite large. But that's the trade-off that we're making here. Accuracy versus size, right? If you want to do something a lot more, if you want to be able to detect a lot more in images, you need to use a much, much larger model, or use, yes, an API. No one said anything. Use an API. There she is again. Everywhere. On cognitive services. But yeah, so we have another one called Computer Vision API, and it just has a much, it can detect many, many, many more things in images. And my colleague Sarah Drasner created another demo on AI.js Rocks which demonstrated this. So she created a demo called the Dynamically Generated Alt Text. And the idea of this demo was, well, can you create something which generates the alt text for images for accessibility reasons automatically, okay, on websites? It's quite an interesting idea, right? And so it's just a proof of concept. So what you can do is you can pass in an image, and it's going to pass it through the API, and it's going to give you a caption. So just reading it out. This is a caption. The top is what the API returns you. And it says a black and white photo of Thomas Edison. The text says, "Hey girl, did you just share electrons because I'm feeling a covalent bond between us?" My voice always trails off because I have no idea what that's talking about. But the important thing I wanted to explain to you, it didn't just say a black and white photo of a guy. It knows this is Thomas Edison, okay? And also extracted text from the image as well. So you can do a lot more than something like MobileNet. But even the computer vision API has problems every now and again, as some very, very helpful people on Twitter pointed out to Sarah. So this is somebody pointed out that this image, it returned a star-filled sky. The text says 4. Not so accurate. The next one, I don't know. The next one could be true. People stuffed animals on a bed. I mean, you don't know, do you? Might be stuffed animals, right? The next one I love because actually I think we were half right for the next one. Half right. Okay. Half right. I'll take that. I'll take that as a win. So just to summarize, and I think if there's one takeaway from this entire talk that you think you should remember, it's just that TensorFlow.js doesn't have any dependencies. Well, the TensorFlow.js that runs in the browser doesn't have any dependencies. The Node version of it, you can actually have dependencies and have it run using the C version of TensorFlow, which is pretty exciting stuff. But if you just want to use TensorFlow in the browser, it doesn't have any dependencies, and you can get started with just a script tag. You can use something on MobileNet. It's a really simple way to analyze images, and I love, when I'm teaching people machine learning and JavaScript, I love showing them MobileNet to begin with, because it's a really fun way to get started. But it's not really that accurate. If you want to do something a lot more accurate, you need to use a much more powerful model, and for instance, the Azure Computer Vision API. Okay. Last one. I saved the best to last. Image to image. Let's just watch it. Oh, interesting. Oh, what's it doing? What is that? Oh, it looks like you can draw the outline of a cat, and it's going to fill in the rest of the cat. Beautiful. Beautiful, right? Amazing. Actually, pretty scary. Okay. This is running in the browser. This is running in the browser. I'm not showing the rest of the Chrome of the browser. This is running in the browser. And it's another demo on AI.js Rocks called Image to Image, created by a guy called Zaid, really intelligent guy, still at university. What was I doing at university? I don't know, nothing like this. And it's using an algorithm called pix to pix, which he's translated into JavaScript, which is very, very interesting. And what it does is it uses, you can pass an input, a sketch, an outline of an image, or specifically to be trained on cats here, and it's going to generate the rest of the cat image. And it's using a neural network underneath, and it's in fact using a technique called GANs, or Generative Adversarial Neural Networks, a very, very interesting space indeed. Right? I'm going to attempt to show you how it works, because I think this is really interesting. Okay? So the generative adversarial neural network, what you actually have is two neural networks that are competing with each other. They're competing with each other. Okay? You have a generator, and you have something called a discriminator. Okay? The generator's job is to generate images of cats. That's its job. It takes as input an outline of a cat, and its job is to generate just a cat image. But remember, when you initialize a neural network, you're going to initialize it with random weights to begin with. So it's going to do a really, really, really bad job of generating cat images. It's probably just going to create static to begin with, right? But it doesn't matter. You get a bunch of different input sketches. You get the outputs for each sketch. You gather them all together, and you combine it with actual real cat images, and you pass that to the second neural network called the discriminator. And the discriminator's job is to be able to tell if an input image is a picture of a real cat or a fake cat. That's its whole job, okay? And so then, but the thing is, again, the discriminator has been initialized randomly with random weights. So it's going to do a really, really bad job of being able to detect whether an image is a real cat image or a fake cat image. It might actually initially say, oh, that's a fake one, and that's a real one. In which case, it's wrong. And then what do we do to tune those weights to become better? We do backpropagation, okay? So if the discriminator is wrong, it kind of tunes itself to become better. If alternatively the discriminator guessed correctly, then the generator is not doing a good job. Okay, so the generator then is tuned, the weights in the generator is tuned so that it then produces better cat images. And then what happens is the discriminator gets better, the generator gets better, the discriminator gets better, the generator gets better, and they get better and better and better and better and better, until eventually you reach a point where the generator is doing such a good job of generating cat images from sketches, the discriminator can't really tell. And then it's kind of done. It's kind of done. We're over. And then what you do is we don't really care about the discriminator neural network. All we care about is the generator one. You basically can save that somewhere as a JSON file, load it with TF-load model, and run it in the browser. And that's the demo that you were seeing before, was just the generator running in the browser. Okay? And then what you can do is you can provide your own beautiful sketches, and it's going to try and generate cat images for you. Okay? That's it. The input is a sketch. The output is an image of a cat. Doesn't sound very useful, does it? I mean, you're not really scared, are you, by this robot overlord taking over? No. Well, it doesn't just have to work with cats. You can train it up on anything. So this one isn't running in the browser. This is running another algorithm called vid2vid. And the images, the sketches on the left are the inputs, and these things, which look like very, very realistic images on the right, are actually generated by the computer. Pretty realistic, right? How about this one for being a bit more freaky? One input, 3 outputs. How about this one? Because before I was showing you an input that was sketches, just the outlines of things. You can train up a GAN using whatever inputs that you want. This input is a segmentation model, so it's kind of an outline, but also gives you an understanding of depth. Okay? And you can make it do something like this. So she's not actually dancing. She's never made this dance move and had herself videoed. So you trained it up on a bunch of images on herself, and these are the inputs. Okay, these are the inputs, so you can make a great video of yourself dancing. It'll be the only video ever of me dancing well, if I created it. But you could do it. And you don't even have to have an image as an input. As an input, you can use whatever you want. Whatever you want. You can even just have text as input. Okay? So the text at the top, that's what is input. And the image is what's generated from the text. So stage 1 is after 600 epochs. Stage 2 is after 1200 epochs. So you can see it's does a pretty good job. Well, I think this is a bit dodgy, but the rest of them are pretty good. How far away do you think we are? How far away do you think we are from being able to type in details of a web application and a GAN generates the web application for us? I don't think we're that far. So just to summarize, GANs learn to generate. They're generative. GANs learn to generate, so they generate new images. They generate new things. It can be whatever they want. But they actually take a lot of compute to train. A lot of compute, more than a normal neural network. So you wouldn't typically, you can, but you wouldn't be able to typically train some of the more advanced stuff I showed you here in the browser. You'd have to run that on the server side using hundreds of servers. But once you've trained one, the model can be optimized and exported in such a way where it's small enough to be run inside the browser. Few takeaways. One takeaway I should say is if you want to learn a little bit more about machine learning and JavaScript and you want to kind of try some things out yourself, you can go to akka.ms Mojifier, and I have a full tutorial, step by step, everything you need to do in order to build something like the Mojifier as a Slack bot, but you can make it do whatever you want it to make it to do. Let me know if you use it. And just a few final thoughts about machine learning and JavaScript. Okay? So as I've really started to talk about JavaScript and machine learning over the last year, there's actually been quite a few people that have kind of laughed in my face about the viability of JavaScript in the machine learning space. And the answer to that is never, ever bet against JavaScript. It's always a bad bet. It's always been a bad bet. But then again, I don't really see JavaScript as being used by academics and data scientists in the machine learning space. It's very, very asynchronous if you're used to working with JavaScript. Python is so synchronous. It makes it a lot easier to do certain hackily quick scripts inside Python. Things that are quick inside Python can be sometimes extremely complex inside JavaScript. But what JavaScript is really, really good for is a language that can be used to productionize a model. So one of the things that Elle and I were really surprised at with our meetup group in the UK was we thought the only people who were going to turn up would be JavaScript developers who wanted to learn about machine learning. But actually, half of the people who turn up to our meetup group are data scientists, machine learning engineers who want to learn about JavaScript. They've got these wonderful models that they've created inside Jupyter notebooks, and they now need to create cool apps using them. Okay? And that's why they're coming to learn about TensorFlow.js. So that's what I see. So I see a future where there's going to be a specialist space, a specialist type of role, which is the machine learning JavaScript engineer. Perhaps you don't need to get your heads so deep and dirty into academic papers, but you do need to know enough in order to be able to take a model and convert it so you can use it inside a web application. Thank you very much for your time.